Good evening, students. This is Tuhin Sir again, and we are back with another episode of friction. The question is right there on the whiteboard, and it shows a man of mass small m pulling a block of mass capital M, and the coefficient of friction between both the man and the block with the ground is mu. The mass is being pulled with the help of a string. If some students may not know that tension always acts opposite the direction of the pulling. Like if you can try it at home, find a long enough string, and uh, attach it with a heavy body, like something like an almirah, or maybe your cot, and try to pull it. Something heavy, something more than 20, 30, 40 kilograms. You will find that first of all, if the string is not tight, you will not be able to pull the wardrobe or almirah or whatever. So for the string to be tight, there has to be tension, and the tension force acts opposite the body in question, which means the wardrobe, in this case capital M mass, will feel that he is being pulled towards the right, which is quite logical. The man, if it's not a very small object, will also feel that he is being pulled towards the left. So tension always acts opposite, away from the body in question. So for the mass M, it's away from the body. For the man also, it's away from the body. Okay, now let's dive into the question. This is from Pathfinder JEE Advanced, and this is a multi-correct question, as you can see. Now, when the man pulls the block, the options are: the block will not move unless the man also moves. Option B is man can move even when the block is stationary. If both move, the acceleration of the man is greater. And D, none of the above. Okay, so I am rubbing this portion out. If I draw the free body diagram, and tension is same for both, if I draw the free body diagram for the block, it will be something like this. Tension force is towards the right, and there is a friction force. And since we have been asked if it is whether it's going to move, etc., so we are going to take the limiting friction, because if the limiting friction will only act if the body has a tendency to move forward, or rather move. So it will be mu mg towards the left, and this for the block. For the man, and this I am taking as the man, tension is towards the left, and a friction force equal to mu small mg is acting towards the right. Now look at, we'll see the options one by one. Let me just open the question again. We'll go to option number B first. The man can move even when the block is stationary. And a few of you would have also figured out one or two options by now. The correct options are A, B, and C. All the options are correct. So we are going to option number B. The man can move even when the block is stationary. Yes, so T is constant here. If T is constant, then if the man can move, if T is greater than mu mg, then the man moves. need not be t is greater than mu capital Mg. If t is greater than, or rather t is greater than mu Mg and mu capital Mg greater than t, if t is greater than mu Mg, then the man moves, but the block doesn't move. So option B is correct. The block will let's now try and attack option A. The block will not move unless the man also moves. Well, the block will not move unless the man also moves. Now we'll see what happens when the man moves. When the man moves, this is mass small m, this is T. If the man moves, and this is the friction force limiting, if the man moves, then T is greater than mu Mg. And we know from the Newton's second law, which is the vector sum of the forces on a body is equal to mass of that body into acceleration of that body. Right? So what are the vector sum of forces? T minus mu Mg is equal to mass into acceleration. Right? So if the man moves and there is an acceleration towards the left, what happens to the T? The tension becomes mu Mg plus Ma. So when the man moves, the tension becomes mu Mg plus Ma. So what happens to the block? The block may move now because the tension has increased. So if you look at the statement, the block will not move unless the man also moves. Here the man is moving, and therefore the tension in the spring has increased, and therefore the block may move now. So option A is correct. The block will not move unless the man also moves. The block will move if mu Mg plus Ma greater than equal to mu capital Mg. So option A is also correct. Now let us go to option C. And option C says if both move, the acceleration of the man is greater than the acceleration of the block. If both move, then the tension which became mu Mg plus Ma. So acceleration of the man will become the net force, which is tension minus mu Mg divided by mass of the man, and acceleration of the block will become tension minus mu capital Mg by capital M. So you can see that the acceleration of the man is greater than the acceleration of the block if both move. I hope I have been able to explain this question. If there are any doubts, please you can come back to me with questions regarding this particular video. I have diverted a little bit from the previous lecture where we were discussing inclined plane, and in the very next video we will be going back again to the inclined plane friction problems. And if you have liked the video, please remember to like and subscribe, which will encourage me to make more and more videos. Thank you very much, students.